I'm excited to be here. Thanks for having me. And as Danielle was saying, like everyone's working with AI, Gen AI right now. Like you're seeing it involved in a lot of different products. I just want to talk about that a little bit. I want to start off with the Gartner hype cycle chart. I think we've all seen this where there's some piece of new technology that comes out. We ride it up to the peak of inflated expectations. We think this is going to change and solve everything for us. Then we start to see the warts and go down into the trough of disillusionment. And eventually realize like, hey, this is gonna solve some problems. It's gonna be useful. It's not gonna cure everything for us. And I think we're riding that hype cycle right now with Gen AI, with LLMs. In terms of like the technology trigger, you could look at like GPT-3 or one of those GPT models, or maybe the Transformer paper, where we started to see, hey, there's some interesting things happening with text and large language models and all that stuff. But it was still pretty niche, right? Like you had to be an ML researcher, you had to be maybe a Python hacker to really get any use out of this stuff. Then we saw 8 months ago, ChatGPT comes out, right? And now it's available to the masses, right? And I can use it for all sorts of different things. You see all these new demos that are happening, and I'm realizing like, hey, maybe I don't need a lawyer anymore. Maybe I don't need an editor anymore. But also maybe people don't need me anymore, right? Maybe I'm gonna become a sheep farmer. I have to go do something real, right? Yeah, exactly. Replacing us all. The good news, I think, over the last couple months is we're seeing a few of the warts and things like that, and the good news is we're safe. Like, it's not going to replace us in the next 6 months or so, but we're sort of coming down in terms of like, hey, it's not crazy what's going on here. I think we're still going down to that trough of disillusionment, but the reality is like this is pretty amazing what's possible here, and it's really going to change how we make software for the next 5 years, the next 10 years, and things like that. So. I agree with Nat Friedman, former CEO of GitHub, where he's saying, even if we don't have any progress going forward, it's going to take a decade to take all this stuff and ingest all those capabilities into the products we already have, which is pretty amazing. So we need to be aware of how to use this stuff. Also, if you look at Swix, he wrote this great piece on the rise of the AI engineer, just talking about like, things that used to take a whole team and 5 years to do is like something I can do now with a spare afternoon with an API key and just do some pretty amazing things. So with that, I want to talk about, embracing generative AI for product engineering, sort of a fancy title here. But the big key is like, I want to set the table for the rest of this conference because there are going to be some great talks on vector databases, on embeddings, on how to use that stuff. We're going to see some great like demos of actual things in production, like from PingCap and things like that. So I want to make sure like, hey, if you're sort of new to this space, or even if you've like dabbled in it, I want to make sure you have a foundation for the rest of the day, get the most out of it. So just in terms of what I'm going to talk about, start off with just like generative AI terms and concepts, make sure we all have the same foundation here, and then go through and look at some common problems you'll run into, and also just how to think about improving your results as you're sort of moving this and trying to improve what you have here. The only way I know how to give a talk is just like 100 slides, so I'm just going to run through as many as I can in 30 minutes here. Who am I? I'm Alex DeBrie. I sort of sit at the intersection of like data and serverless and AWS and just really love all that stuff. I'm an AWS data hero. I do a lot with Dynamo, so I'm grateful for Kwaja and Danielle and their work there. I've just been playing around with this space a while as well. All right, cool. So let's get started with just sort of terms and concepts. I think we've heard like some of the AI, machine learning, and then just some of the LLM concepts floating around, but I think it can be hard to like categorize these if you're not like fully in that space all the time. I'm mostly looking at this from the space of like people that are building stuff with them and not necessarily training models or building models themselves. So hey, no math, we're not gonna like go through transformer architecture deeply or anything like that, right? We're just gonna go high-level terms and concepts if you're building with this stuff. So just starting off with machine learning, I think we're probably mostly familiar with that, but I want to make sure we have that foundation as well, right? In traditional software development, we're going to bring the business rules, right? We have some product, we have some feature we want to implement. We're going to sort of think about what are the steps we want to have, what are the constraints and rules we want to enforce here, and then we'll write that out, right? So if we're doing like a car rental application, right? You have someone wants to rent a car, you want to make sure, hey, is this driver, allowed to rent this car? Is that car available? Did the payment go through? You can go through that thing, go through those steps to make sure they work. And that works well for like a huge array of domains here, but there's some domains like where that doesn't really work, right? And the common example here would be like image recognition, right? If I give you an image, can you tell me if there's a dog in that or not, right? And you could think about the different rules sort of like spelling that out, like, hey, does it have fur? Does it have floppy ears? Does it have a wet nose? Like all these different sort of like if statements and things like that, which would be very difficult, but like if I had a 2-year-old, they could easily tell you, is this a dog or not? It's something that as humans, like all you need is some data, some examples to sort of understand those concepts. So that's where, with machine learning, it's sort of flipping that around, where in machine learning, you bring the data and the model brings the rules. So maybe you have, 10,000 images of a dog, 10,000 images of a cat, they're all labeled, and sort of understanding what's going on there, the model's gonna train that and generate those rules. So we're not specifically building out the rules that way. Now we're just interacting with our model and say, hey, is there a dog in this? And that model is building some of that stuff out. Right, so that's basic machine learning. We've seen that over the last 10 years quite a bit. Let's go into LLMs, ChatGPT, how does that stuff all work, right? So LLMs, hearing a lot about those. Stands for large language models. So this is a model just like these other machine learning models. It's a large language model, right? So it's going to be text-based. It's large. It's built on a ton of textual data. We're talking hundreds of thousands of books. We're talking the whole internet, all your Reddit posts, all those sorts of things right there. These really took off in 2017 with the advent of the transformer architecture. So if you want to get down into the papers, like attention is all you need. This is from the Google Brain folks. Like really, I think just added this new architecture that really enabled GPUs, really enabled parallelization, and just like larger models with more capabilities is where this really took off. Within this world of large language models, we have sort of 2 families of models. I think the original ones, were like the BERT model came from Google, came from a lot of those same folks that did transformers. And this is kind of an interesting model where it's like looking at the text and sort of processing it in both directions, right? And understanding like, okay, the context of each word depends on stuff before it, stuff after, if you really want to understand the context of that word. And this is great for another number of applications, right? Like classification, like is this positive, is this negative, or does it fall into some sort of bucket like that? Or maybe translation tasks where you're gonna look at the entire text and translate the entire text. That works really well. So that was great, but then the GPT models, which we're more, I think, familiar with now, this is slightly different. So this is a generative pre-trained transformer being that transformer architecture, pre-trained, trained on a bunch of data, able to apply to a bunch of different domains. And then generative, which is the interesting thing, right? It's just going sort of left to right and able to do completions and sort of guess what the next word will be and interesting things there, right? And that leads to ChatGPT, which I assume most people have played with and looked at a little bit. In terms of ChatGPT, been out 8 months, and I'd say the big improvement with ChatGPT is really just around usability, right? And how you're actually doing it. It's more of like a usability improvement than a better model. This was a slightly better model than GPT-3, which had been out since 2020, but not so much. It's really about those usability improvements, right? And what are those usability improvements? First one being just like a web UI, right? You can actually use this in your browser rather than having to download a model, hack together some Python or C++ to make this stuff work. You can go use it in a web UI. So now like my brother-in-law, he's a urologist. He used it to plan a family vacation. He used it to like draft emails, all sorts of things. So just opened up the scope of like who could use this stuff. One of the other improvements is it's chat-based, right? And it's sort of pulling in those previous messages. So you don't have to like resend the entire message every time. It's pulling in those previous ones, so it feels like talking to a person that understands like previous context and things like that. And then finally, those streaming responses, right? Where if you have these generative models that are sort of predicting the next word one at a time, if it's generating 1,000 or 2,000 words and you waited for that entire thing to complete, it's going to sit there for 30 seconds or a minute. It's going to feel like it's not working. But just doing that streaming responses, it feels like someone's actually typing back to you, right? Or if you're using the ChatGPT app on your iPhone, you get like the tactile sensations. I think all those sort of improvements, right? Those are all just like usability improvements. And I think that's probably the biggest thing for us to be thinking about as product engineers and builders that way, of just like, hey, these models are good enough to do like really amazing things. And it's really that like usability and just like how we think about the interaction with our data, with users, to make that really work well. All right, so that's basics, LLMs and ChatGPT. Just some additional context, right? You'll hear about the word context a lot. When we talk about context, that's just like what you're sending and receiving back from a model, right? So you'll hear about context windows. That includes both what you send to it and what you get back. So that input, you might hear it as a prompt, and the output that you get back, you might hear of that as completion. So context, input plus output. The big key is like models are gonna be limited here, right? Each model is gonna have some sort of maximum context window that it can handle. Often like 4,000 to 8,000 tokens, but now you're also seeing like 16 and 32,000 tokens, all the way up to like 100,000 tokens if you want to use something like Anthropic, which is pretty cool. But the key to note here is like, hey, it's that input and output combined. So the longer prompt you sort of send in, the fewer context you have available for your output back. You'll hear about this talk about in tokens, right? What are tokens? I use words. So if I take this, if I take my actual prompt here, you can go to OpenAI has a tokenizer that shows you how this translates to tokens. And tokens are basically like commonly used either words or subsets of words. So this prompt here has 112 tokens. You can also just see it'll cover that for you and show like what that is. A lot of those words are full words will be tokens, but sometimes they'll split it up, or punctuation will be tokens, different things like that. And again, you're gonna be charged, if you're using one of these like hosted models, you're gonna be charged on the context you used. Generally, output is gonna cost you 2 to 5 times more than input. So I think it's just like just to help you with your mental model of understanding like, hey, completion is about 2 to 5 times more resource intensive than processing that input, which I think is useful. All right, you also hear about shots like, hey, ChatGPT is a 0-shot learner or a 1-shot learner, or you should use like a few shots in your context. What does that mean? Shots are basically just like relevant examples that you're gonna be including in your prompt, right? So I showed this ChatGPT interaction here before. I was just like asking it, give me some dad jokes. I love a good dad joke. This is a zero-shot prompt, right? Because I didn't have to give it any examples of what I want. It knows what a dad joke is and can give me those back, which is great. A couple things to note here, just look at like how it formatted those back, right? It numbered those back to me. It sort of has the setup, and then the punchline is indented there. If I go and do like a one-shot example, right, maybe I'll give an example of a particular joke that I like here. And one thing to notice here, it gave me basically the same jokes back, a little bit different, but notice how it started to pick up some of my formatting stuff. So I said I had like a Q&A type format, and it sort of matched that down below with the 1, 2, 3. I tried again with like a few-shot prompt where I have a few jokes in there. I tried to give it some jokes about dads, so see if it would give me like dad jokes and pick that up. It did not, but one thing you can look at is like it really started to copy my format even more. Now it's not numbering them, it's doing that Q&A type format. So when you start to give your models some examples or shots, it's gonna pick up some of that context, and it might pick up some stuff you didn't sort of intend for it to pick up on that, so be careful with that. So shots are just relevant examples. You want to just give it more examples often to help narrow down that answer, give you a more accurate thing, especially if you're in a domain that it might not know that much about, right? Like dad jokes, there are plenty of dad jokes on Reddit. It doesn't need to need any examples there. But if you have a more constrained domain, you can give some examples. It'll help you out. The big thing to watch out though is overfitting too much to your examples, or just like picking up other sort of subtle things in your example, like the formatting I had there. Let's talk about embeddings a lot too, which is super relevant in the context of Memento Vector Index, right? So what are embeddings? Basically just a vector of floats, or if you're like me and don't have a computer engineering degree, it's like an array of decimals, right? It's gonna look something like that. These have been used for a while, and basically what you're doing is you're taking like very high dimensionality data, like an image or a giant book or a chunk of text, and turning that into a lower dimensionality representation. If you want to check out some cool stuff on this, like the Word2Vec paper from Google, I believe, in 2013, this is super interesting as well, where they showed like you could do like math on words, kind of, right? They would train these NLP models, and then they'd feed these words into them and get the vector back, and then you could do things like, hey, if you took the word king, subtracted man, added woman, it ends up being similar to the word queen, right? Which it has all the aspects of kingship, the royalty, the things like that, but change the gender there, and you get queen. So like kind of interesting how you can do math on words like that. So vectors, Embedding's been used in a lot of machine learning applications. Recommendation systems been using these for, encoding user preferences, different item attributes to recommend stuff there. If you're talking about images and videos, taking all those pixels, all those frames, turning those into vectors to do processing on that. And now with LLMs, you can take paragraphs, you can take whole web pages like Danielle was showing in the demo. You can take product reviews, you can take function calls if you're working with your actual function code and turn those into embeddings and do things like similarity search on those and things like that. All right, so let's just close off with use cases, and I want to talk like very high level use cases, just sort of architecturally what that would look like, right? The common one is going to be text generation, ChatGPT. We've seen that. I'm sure a lot of us have used GitHub Copilot as well. But anytime where you want to have like very creative or just like a wide search base of like text generation that you want to have, right? So we've heard Stack Overflow recently, they're like releasing their own AI model, and you can imagine they have a user, and rather than searching for like an answer that's like close to what they want, they could ask a question like, hey, will you just give me a React component that does this? Use a use context hook to do something. That could go hit their AI model. It's going to come back with an actual example that's relevant, exactly on point for what they want to do, and sending that to the user. So that's just like high-level architecture for what that text generation use case will be looking like, right? You're taking some user prompt and sending it back to that model for generation there. A second high-level use case will be that embedding and relatedness one that's relevant to that Memento vector index. So what that looks like, is now you pull in a vector database. If I'd have known that vector index was coming, I probably would have put that on here, but I couldn't change my slides in time. But Pinecone, Weaviate, something like that. And now if you have some sort of data that's maybe not in the model, or you want to add in, maybe some user documentation, or maybe you have like a knowledge base or something like that with a lot of questions over the years, what you can do is now go to your model, generate those embeddings of that text, like we were saying, turn that into that higher dimensionality representation, and then put it into your vector database. And now when a user comes with a question, and if they have some super obscure question, rather than doing like exact term matching on your documentation, which might not be as relevant as what they want, it can sort of understand what they're really looking for. You take that question, turn it into an embedding, and then you go hit your vector database and say, hey, give me the documents that are most similar to this, right? And so rather than matching here on something like VAT or German or something like that, it can say, hey, what they really want to do is be able to edit an invoice. Or add special details to an invoice. How do I help them do that? And you can give them something more relevant there. All right, last use case is going to be kind of a combination of those, retrieval augmented generation, where maybe some sort of user action comes in, whether that's a query or just some button clicks, things like that. And you want to like find some relevant context first. Maybe you want to search your documentation. Maybe you want to search something about that user. And then you take that context and you embed it in your prompt to that GPT model. So you're sort of doing both. Maybe you're using embeddings and that relatedness, but you're also using that text generation pattern. And those are just like, I would say, the three sort of high-level architecture patterns we have there. All right, cool. So let's run into some problems that you're going to run into, because I think this space is super different from like traditional software engineering and the difficulties you're going to run into. The first and most difficult thing I think is just like the non-determinism of working with a probabilistic model rather than like deterministic code, right? If you're doing this sort of car rental feature and a user says they have an error, you can ideally go back, reproduce that, and figure out, hey, which of my rules was wrong, or what part of the state was wrong that made this not work. But you don't really have that as much in this probabilistic model. We also have a lot of tools to understand if this is going to work when it gets into production and make sure we don't have regressions, unit testing, integration testing, different things like that. So that non-determinism of working with this generative model is difficult, and especially around testing. Also, just like a subtly weird part about it is just like the structure of the response you get back, right? Like if you're working with ChatGPT and it gives kind of a different structure than the format you gave in, that's all right. You can parse it as a human. But if we're building these into our products, now we need some sort of structure to like programmatically work with this stuff. And often you're going to want JSON or some sort of schema back, but even that can be difficult. And like one of my favorite stories here is this guy, Riley Goodside. He's like interacting with Google Bard. So it's Google's like ChatGPT type thing, right? And he's like, hey, give me an example of a JSON dictionary. And he says, don't include any text other than the JSON, right? And it comes back and says, sure, here's an example of a JSON dictionary with 2 keys, blah, 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 gives the JSON and a bunch of other stuff, which if he were interacting with this programmatically, it'd be hard because it's going to barf on that text like outside of the JSON, right? You just want the JSON back. So then he goes and makes example 2, and he's a little more forceful here. Hey, don't include any text. The text before and after should be exactly 0, nothing else. He also says, hey, here's some examples of things you should not say, right? Like sure, here's an example of a JSON dictionary with 2 keys, right? And then he gets more forceful, like do not do this, whatever you do. Don't give me any other text. And his response, and like sure enough, look, it even says the exact thing. The exact thing he says not to say. Sure, here's an example of a JSON dictionary with 2 keys. All right, so one more shot here. He adds this last paragraph. And he's saying, you might be wondering why I'm so emphatic about this point. He basically says, if you include any additional text, an innocent man will die. Right? Let's see, does Bard care? Is Bard aligned? Bard just gives us the JSON back, right? So the Bard's still aligned with us, but the point is you don't want to have to include all that nonsense boilerplate just to make sure you get proper JSON back. And this is a silly example with Bard, ChatGPT or the GPT models have been sort of tuned to be better than this. There's improving with that. They also have function calling that you can use to get a schema back. But it's just this weird thing you're not used to of just if you're writing the rules yourself, you're not expecting to get some goofy structure back because they just decided to add some helpful, sure, here's a dictionary text, right? So goofy things like that. Also around non-determinism, just understanding improvement, right? And if you're making changes to your model or making all these different tweaks, how do you know if what you're doing is actually making it better for your user, right? And often you have a privacy issue here, right? Depending on the industry you're in or just the product it is and the expectations around privacy, you might not be able to get access to the user prompts and the result to see hey, are these actually working out? You need to figure out how do you close that feedback loop? So non-determinism, I think that's going to be the biggest problem we have. There's some other problems too, just missing data, right? It's amazing. You can go to GPT and learn all sorts of things in history about Napoleon or Charlemagne or whatever you want to do. But anything that happened after September 2021, it has no knowledge of, right? Because that's the data it's been trained on. So you can ask it something on that and it might not know, or in conjunction with that, it might make something up, right? So hallucination, where it actually just makes up details and sounds very confident doing so. And sometimes this is good, right? Because I asked it once, who's Alex DeBrie? And it gave me all this stuff. It also said that I wrote serverless architectures on AWS and that I'm the host of Real World Serverless podcast, which I'm not. That is Jan Trey, the Burning Monk. So, but I'll take credit for it, right? But it just very confidently said these things without understanding that it's wrong. So those things can be tricky. I think the big thing you want to think here is, like Sam Altman said once, don't think of these things as a fact database. Think of them as a reasoning engine, right? And you want to sort of feed the facts in where you can and then use it to do the reasoning or different things like that. Another problem is just around prompt injection, right? We hear about SQL injection. Whenever you have some sort of user input, right, that can be dangerous. What can you do here? Prompt injection, I think you see a lot of examples of people getting around prompts that people are sending out and being able to get sort of the meta instructions and things like that. I think on some level that's difficult or impossible or just not worth the effort to truly avoid if it's just around hey, them getting the sort of meta instructions around your chatbot. But you do want to limit your blast radius. And if you're hitting an LLM and then based on that output, querying your database or inserting records into your database, be very careful that someone's not breaking out of that loop and now altering data in a bad way or getting access to data in a bad way. And finally, the last problem you'll have there is just latency, right? This is not it's not as fast, as calling a key value store or even a relational database. It takes a while to generate these prompts. So think about how to work with that with your user. All right, so given all these problems, right, I want to talk about, just close out with improving your results. Because often you're hey, I have an idea how we can integrate this into my product. Maybe you start it with ChatGPT or a LangChain demo and you get some really cool stuff that's 60 or 70% there. And then it can be really hard to make it much better after that. So what are the different knobs you can turn, the levers you can pull to improve your results? I think of 4, right? The first thing you can do is just choose a different model, right? So if you're using OpenAI in your architecture, you could choose, hey, maybe I'll use GPT 3.5 or GPT 4. You could also look at Anthropic. Maybe you need a larger context window. Maybe you want to host your own, use Llama 2. Or you can go to Hugging Face, and there are literally like thousands of models you can look at that are all tuned to different things, right? So in choosing your model, I would just sort of recommend defaulting to OpenAI GPT. Like these are, I think, the most cutting edge models, the best models out there. In general, I think GPT 3.5 is fast. It's faster, it's cheaper, and it's good enough for most use cases that I'd sort of recommend starting there. Although you can look at GPT-4 depending on like how important it is to have like really high quality results and if your users can tolerate a little more latency there. If you have really high context needs, then something like Claude's Anthropic from Claude from Anthropic, has a 100,000 context window, which can be useful. If you need to host your own, Llama 2 from Meta is probably the best one. It's mostly open source as long as you have fewer than 750 million monthly active users, which my project is just under that, so I'm okay. So yeah, that's a good one. But really, there are a lot of models out there if you want to test different ones. I don't know how much mileage you'll get from that. You can see, but really the GPT models are pretty good. Second option you have here is to fine tune your model, right? Which, again, if we have this model, it's been pre-trained on a bunch of data, but we might have data that's outside of that data set, right? Whether it's our documentation, right? Memento has been created after 2021. So it's like not even in the training data set for this stuff. So maybe their user documentation, or maybe a lot of like domain specific information. If you're working in the medical domain, or maybe a different language or something like that just doesn't have as much training data, you can take that and fine tune an existing model by feeding labeled data to a pre-trained model, and now can sort of learn that stuff as well. And then you can query that updated fine-tuned model. So with this, what you're doing, you're augmenting a trained model with new data, often getting around that knowledge cutoff, or if you have very domain-specific information. This is kind of tricky, especially because hey, I'm recommending GPT, but you can't do this with GPT 3.5 or 4. You can do it with 3, but those models are getting deprecated pretty soon. So you're kind of out on an island here. I think the bigger problem is now you have an ML ops problem, right? You need to figure out, how do I get a bunch of really high quality labeled data? How do I make sure I'm updating that model well? And just if you're not used to that, if you're getting into this for the first time, that could be a hard problem for you. All right, third way to improve your results is just to increase the context, right? We talked about, few shot learners and things like that. So just giving it more shots. I think a lot of people want to reach for a vector database for this, and this can be very good for a lot of situations depending on what kind of input you're getting from the user. But don't sleep on just going to your OLTP database and getting information about your user, right? If you know that your user is gold status and has 3 flights coming up, that could be good context to embed as they're working with a chat agent or something like that. So be looking at that, increasing the context. And the big patterns here is, adding more shots, more examples to your prompt, adding more context about your user to that. And then finally, as we talked about with ChatGPT, including more of that conversation so it feels more like a conversation rather than just a series of isolated requests there. The one thing I would say is more context equals higher price, right? And also maybe not as good a results. Some of these things have bigger context windows. It's hard to tell how well that works, but there are some people saying, hey, they're actually not that good at processing all this context, so it might not be that useful. So that gets us to the last knob we have here is just improve your prompt, right? Spend some time tuning your prompt. I think this was called prompt engineering sort of early on, and people thought prompt engineer was going to be a hot new job. That's probably not the case, but I think we're all going to need to understand how to prompt these things and just stay on top of what's happening in the different patterns, React, chain of thoughts, tree of thoughts, things like that, and understand and test it out. I think the biggest thing here is you want to iterate through this and test and just see what's working. The hard part here is getting that feedback loop to understand, are you actually getting better? So figure out some sort of feedback loop to make that better. All right, I just want to close with putting this to use, because as I was going through the slides, I realized I was giving sort of a bunch of maybe negative things, or don't do this, right? Don't use retrieval augmented generation, or don't evaluate custom models, just use GPT. Don't overuse context, it can't understand it anyway. Don't fine tune too hard, ML ops, avoid GPT-4, and sort of just prompt, right? And it feels like all these negative things. And the reality is just generative AI stuff is hard right now. It's a new pattern, it's a new tool. We don't have all the knowledge on how to use it well. We're gonna have to figure that stuff out. But I also say hard is where the alpha is, right? If you want to distinguish yourself as a company, as a product and things like that, you're gonna have to do some hard things. Because otherwise, if you're not, we're talking about what Swick said, anyone with a spare afternoon and an API key can play around with this stuff and can play around with GPT 3.5. And so if that's all you're doing and you're not doing any of that extra stuff, it's gonna be hard to distinguish yourself. So I would say like all these things individually might be good advice, but I would also say like, don't be scared of taking on a few of the hard things and understanding like, okay, I'm actually going to fine tune because I think it can work for this reason, or I'm gonna use a different model, evaluate some different models for this reason. Like, don't be afraid of that stuff because that's how you're actually gonna distinguish yourself. So that closes out. I hope that like helped everyone just understand what generative AI stuff is. We talked about terms and concept, common problems, improving your results. Like, gonna be a lot of really great in-depth talks on different things here. I hope this set the table for you there. So thank you.